Okay, next I will continue with the advantages and the problem of downhole separator technology. Okay, for the advantage of downhole separator and what it brings to the table. First, as in the introduction, as I said, downhole separator technology will reduce the total cost of production of oil and gas. Downhole separator technology reduces more than 70% of the water that was supposed to be produced, thereby reducing the total cost of lifting, treating, re-injecting, and disposing of produced water. This will be greatly impacted by how the engineer will carry out their production without worrying the water that must be treated. Hence, they will be reusing the water to re-inject in the formation. By doing so, the cost of production of oil is greatly reduced. Okay, based on the image on the side, downhole separator installation reduces the production of excessive water. Second, prevention of pollution. Downhole separator technology can cause reduction of environmental impact of oil and gas operation. Standard injection well operation pose a significant but manageable risk of environmental pollution. The highest risks occur due to surface spill during the injection of the separated brine. By reducing the produced water that will be brought up to the surface, hence there will no spill or less spill. By reducing the amount of brine brought up to the surface and re-injection occur, the environmental risk associated with re-injection wells can be reduced. Okay, 3. USDW protection. What is USDW? USDW stands for underground source of drinking water. Pollution of underground source of drinking water. Produced water in most cases contain brines. With downhole separator technology implementation, the engineers can protect the aquifer in the formation that can be used in the future as underground sources of drinking water. With the downhole oil water separator technology, dissolved impurities are not allowed to get to the surface, hence they do not pass through interval containing underground sources of drinking water. Also, since the water does not require re-injection for the surface, it will not pass the aquifer. Okay, for the fourth advantages of downhole separator, because downhole oil water separator technology uses underground equipment, surface brine disposal operation, which is produced water disposal operation, which may involve pumps, pipes, tank batteries, and other storage facility, also can be reduced, hence minimizing the facility size and causing the additional cost of facility can be reduced. And lastly, the downhole oil water separator system is used for re-injection, thereby increasing the drawdown pressure in the formation, which can result in increased production rate for the oil and gas production system. Okay, not all technology have all the advantages. There is also a problem with downhole separator. Mostly the problem occur for the downhole separator technology from the machinery of the technology, and also the problem comes from the formation. Okay, the first problem that comes with the downhole separator technology is injectivity decline. In order for the downhole separator technology to function properly, the injection zone, which is the formation, must have sufficient permeability and porosity to accept brine at pressure within the capability of the pump. Inappropriate fluid contacted sensitive sign can damage the part of the permeability. As the graph on the beside, as we can see, the injectivity decline will increase if the pore volume injected is decreased. Particles in the produced water clog the injection zone. In fact, injectivity decline caused by the various contaminants in the water phase widely exists in water flooding operation. When the injection operation occurs, it's not only water that will go in the stream. It's also containing the sediments, the participation of chemical additive. This phenomenon is referred to formation damage, which can lead to serious loss in productivity or injectivity. It is a problem also to feed the separator inside the well, because the equipment in particular must be fed to channel to bypass oil flow around the pump, and motor assembly must be fitted into a very small cross section and are exposed to very high flow rates from the production process. This can create a risk of erosion or corrosion for the equipment. Okay, the second problem that comes from the downhole separator technology is solid plugging. Excessive sand not only damage the injection zone, as the previous point, they also result in premature mechanical failure of the separator pumps or bypass tubing. Okay, as the diagram below shows that depletion increase effective stress. High velocity of viscous fluid can move sand. Hence, when the sand moves in the formation, it can cause damage to the equipment. Okay, in at least 2 cases, solid production was so excessive that the entire pump or separator assembly was packed with solid when inspected at the surface. When the produced water go into the stream, they also will bring any sands or rock that can cause damage. In one case, also the solids were formation solids, and in the second case, the solid were iron sulfide scale, which is the additional chemical additive. Okay, next problem that comes from the downhole separator technology. To protect the producing reservoir, the injection zone must be adequately isolated by an integral confining zone and sound cement behind production casing to prevent the formation from collapsing or from damaging the equipment. If isolation is not sufficient, the separated water can migrate into the producing zone and then short circuit into the producing perforation. This can create problem as we want to produce pure oil without any addition with water that can cause problem when we treat and producing the oil and gas. The result will be recycling of produced water with oil production rates dropping to nearly zero because the water will overwhelm the production of oil and gas.